Hey guys, welcome to section 5, chapter 6 of the geometry program. This is your final section for first semester. So congratulations, you've made it. In this section, we're going to focus strictly on kites. So we're not actually going to do the book section. We're going to focus on kites because you're going to see more of that than isosceles trapezoids, which your book also covers. Here's a couple of theorems for you and a diagram for clarity. So a kite is a little weird. Remember, it has two sets of congruent sides. So that tends to have a set of sides longer than the other, right? If they were all the same, then we would call that a rhombus. But a kite has an elongated set of congruent sides. And then you have two sets of angles. You have in red here what's called the vertex angles, which are going to be like your elongated side of your kite. And then the non-vertex angles here are your shorter ones. And the reason that's important to denote is because of our theorems. For example, the non-vertex angles of a kite are congruent. So that means this angle is congruent to this angle. It does not mean that this angle is congruent to this angle. It means of these non-vertex angles, those two are congruent to each other. And then another theorem, the diagonal through the vertex angles is the angle bisector for both of those angles. So again, side note, have you guys ever practiced drawing kites? It is particularly hard. Maybe in your assignment tonight, you should practice drawing some of these. And I don't have a shape drawer for me on this program, and so my kites are really pathetic. But you should try it and see how hard it is to draw. Okay, so this second theorem says that this long diagonal is going to bisect the angles here on each side. So this angle bisects and this angle bisects also. All right, again, it's not true for the short diagonal, but it is true for the long diagonal. All right, and then one other thing, the diagonals of a kite are perpendicular. So if you go ahead and draw in the other diagonal, you're going to see a right angle there. They're perpendicular. All right, so when you get done with that, let's jump into a few examples. Like this whole chapter, I feel like the application is not nearly as challenging as sometimes just writing down the theorems and trying to understand them. So remember, in a kite, we have two sets of congruent sides, so just be really attentive because on some of the shapes, they might throw you a little bit and make a rhombus. Remember, a rhombus is going to have four congruent sides. So for example, in this example, if you want to find x and y, you have to be able to match up the side. So this side is a single line, and this is a single line, so they go together, meaning x has to be 12. And the double dash here goes with the double dash there, meaning y also has to be 9. Okay, so just be attentive to which pieces are congruent to each other. Okay, then we had another theorem that said that long diagonal bisected the angles. So if I know that this small angle is 35, well, x has to be the same. It bisects it. Similarly, y. If this side is 25, that long diagonal bisects it, and this guy also has to be 25. Again, not true of the short diagonal necessarily, but it is true of the long diagonal. All right, then you might have a question that asks you to find the missing angle. And the piece, well, there's two pieces here that you need to know, or at least remember. The first is the sum of the interior angles of a quadrilateral. I'm not sure we've ever explicitly stated this. We've worked with it in previous years, but it's worth saying. So just like when we added up all of the angles of the interior of a triangle, it added to 180. Maybe you know this, maybe you don't. But the four angles of quadrilateral are always going to add to 360. We actually had a theorem that helped us find all of the sum of the interior angles in a previous chapter. But it's worth noting and remembering that particularly in a quadrilateral, those angles are always adding up to 360. And that's the piece we need here, because if we remember that these non-vertex angles are congruent, meaning this has to also be 7x plus 20, then I can set myself an algebra problem and set it equal to 360. So if I'm adding all of the angles together, plus 8x minus 1, plus another 7x plus 20, all of that equals 360. And then I should be able to solve. All right, so let's combine all of our x's here. We're going to get 22x. And then if we add our constants, oops, looks like 96 equals 360. And if you solve that down, so if you solve that down, you're going to get x equal to 12. But remember, they didn't ask us to solve for x. They wanted us to find the measure of angle E. We know that E can be found if we substitute 7 times 12 plus 20, which is going to give us 104. So the measure of angle E is 104 degrees. So 2 pieces of information there that we needed. We needed to know that the 4 angles of a quadrilateral add to 360, and that the opposite angles of the short diagonal, or the non-vertex angles, are congruent in order to solve that. All right, let's do one more. So again, matching up congruent sides, it asks us to find the side TS. Well, I know that TS is congruent to QT, meaning 2x plus 8 is equal to 3x plus 3. And then we're going to solve this. Subtracting 3 from both sides, we get x equals 5. But I'm not done yet because it asked me to find TS. So now I got to make the substitution. So 3 times 5 plus 3, and TS is going to be equal to 18. So make sure that you are answering the question that they ask. Don't just solve for x and move on. They might be asking you for the actual like angle measure or the side length. So be careful. All right, that's it. Finish up your notes and begin your assignment.